Hi, my name is Yuri Kim from Korea University, and I will be presenting my poster, Programming Education Using a Functional Programming Language. More specifically, it is about the integration of the clean programming language in introductory programming courses and how it can enhance learning experiences for beginners. I would like to shortly explain why we thought this study is needed. It is because almost everything around us has been touched by the power of programming nowadays, and as a result, an increasing number of individuals, even those without a background in computer science, are motivated to learn programming. So basically, the need for effective introductory programming courses has significantly increased. And one of the main things that can greatly influence a student's initial experience with coding is choice of programming language. This choice shapes their understanding, engagement, and overall success in learning programming concepts. Many programming languages come with complex syntactic and semantic features that can be challenging for beginners. These complexities often lead to frustration and disengagement, particularly for students without a strong technical background. So, selecting a language that simplifies these complexities is crucial for fostering a positive and productive learning experience. And we think incorporating the clean functional language into introductory programming courses can enhance the learning environment for beginners. Probably most of people are not familiar with the clean programming language. Clean is a functional programming language which was intentionally designed with a minimalist syntax. It rooted in mathematical functions mirroring their syntax and structure. So, this resemblance to mathematical functions can simplify the learning process for beginners. Clean can minimize the burden on learners' memory by minimizing the language syntax. And unlike other object-oriented languages like C, Java, it provides a relatively simple control structure. So the challenge of selecting the appropriate control structure when translating an algorithm into programming code can be avoided. The absence of an abundance of control structures can enable Clean to excel in code expression efficiency. Even if Clean has a small set of control structures, it is capable of expressing any algorithmically implementable and solvable problem. Clean has also enhances the readability of programming code by employing a smaller set of syntax and reducing the length of code lines. And outside of their simple syntax, there are some list of features that might clean suitable for introductory programming courses. For example, Clean, unlike other general object-oriented languages, enforces immutability and does not allow mutable data. Once a value is assigned to a variable in Clean, it cannot be reassigned to a new value. This mutable state can be challenging concept for programming novices and can burden their learning process. The complexity of mutable state arises from its ability to be modified from multiple locations over time, making it difficult to track and reason about the flow of data and control in a program. This complexity can be overwhelming for beginners, but Clean eliminates the concern of mutable state altogether by enforcing immutability. Clean simplifies the mental model required to reason about code, alleviating the burden on reducing the likelihood of common mistakes. This feature makes clean and easier language for beginners to work with and promote clearer, more reliable code. And also, clean is a strongly typed language that does not require explicit declaration of function types. The compiler deduces the types from the information present in the program. Employing a static type system ensures the prevention of dynamic type issues. When a program is successfully validated by the compiler, it guarantees that no type related failures will occur during its execution. Clean also provides the ability to use functions as arguments and return types in other functions. This allows for the creation of more flexible and reusable code where functions can be dynamically composed and manipulated. Clean offers several higher order functions, including map, filter, and fold. These functions provide convenient and expressive ways to manipulate collections of data by applying operations to each element or selectively filtering elements based on specific criteria. By leveraging these higher order functions, novices can write code that is concise, modular, and focused on the problem solving aspect rather than low level details. And Clean supports polymorphism, which enables the use of a single function to operate on multiple different types. This promotes code reuse and abstraction, allowing programmers to write generic functions that can work with various data types. So these are the main reasons why we suggest Clean as an ideal tool for introductory programming courses. And our study focuses on four main objectives related to the Clean programming language in introductory courses. First, we aim to evaluate the potential benefits of using the Clean programming language in introductory programming courses. And second, we compare Clean with traditional languages like C, focusing on basic programming tasks such as sequencing, conditional statements, iterations, and termination. And third, we analyze how Clean's features such as immutability and a robust type system impact the cognitive load and overall comprehension for beginners. And finally, we aim to provide insights into how adopting Clean can enhance engagement and success in learning fundamental programming concepts. So, to assess the influence of Clean on code solutions, we conducted a comparative analysis between Clean and the C programming language. So, randomly selected sample programming problems were used for the evaluation. And our analysis shows that on average, C code required approximately 6 times more lines and 4 times more words than clean code. And the most notable differences were observed in cases involving recursion, as clean being a functional programming language excels in handling recursive algorithms. And also, when working with lists, clean support for higher order functions and list comprehensions enables effective problem solving approaches. So, this highlights Clean's ability to produce concise and readable code. Although we assessed a small sample size for now, we are continuing the evaluation for this study on various other samples and will evaluate at least hundreds of different samples. So, in summary, Clean's immutability, advanced type system, and Higher order functions promote flexible and reusable code solutions, making it easier for beginners to understand and reason about their code. Higher level abstractions in clean, such as list comprehensions, enable efficient and expressive solutions. This reduces the cognitive load on beginners and ease their learning process. So based on our findings, we can say integrating clean into introductory programming courses might create a more beginner-friendly learning environment. Clean's mathematical function-inspired syntax and high-level abstractions allow students to focus on understanding fundamental programming concepts without being overwhelmed by complex syntax rules. This approach does not only enhances comprehension, but also fosters problem-solving skills essential for any programming discipline. The comparison between Clean and C demonstrates that Clean can significantly reduce the amount of code beginners need to write, thus minimizing potential sources of frustration and error. By simplifying the coding process, Clean helps maintain student engagement and support a smoother learning curve. And for future work, we plan to conduct a substantial user study to assess Clean's actual impact on the learning, comparing it with the other programming languages. And this will provide deeper insights into the benefits of employing functional programming languages like Clean in introductory programming education and help in developing more effective and inclusive programming courses. So, in conclusion, I'd say Clean programming language offers a promising alternative for introductory programming courses, helping to simplify the learning process, reduce cognitive load, and improve students' engagement and success. And this is it. Thank you for your attention, and I'm happy to take any questions you might have. So, thank you.